I'm wondering when you describe these concepts, can you show some code examples? Because just by showing the heading and then talking about it, it doesn't. I mean, it's not.
Yes, I have a lot of code samples when I actually cover the steps, marks, and stuff like that. And this TDD cycle, I'm going to give you that Fibonacci factorial and things, and I'll be actually going around. See, that's more like it's what you do is daily. You know, the things that you go through. You know, if you're like working for 8 hours, you're doing TDD. The kind of things are aware of, and the kind of things you actually do. It's like more like a decision-making process. What you focus on, you know, how you write the test, what test to write first. Conceptually, you need to know, you know, how do you pick the first test to write? You know, am I doing the right thing? What is the next test to pick, for instance? And if you have once you have a series of tests, how do you maintain the existing growing test suite? Those are the things which will actually help you. Not, you know, yes, having code can illustrate some concepts. Definitely, I will be having some sample code, and also I'm going to let you work on some things, and I will be actually helping you. It's not about the actual problem itself. I want to focus more. I can even give you the equation, right? Solve problem. Okay, this is a problem, this is a solution to make, this is a solved problem. I want you to focus more on the red-green refactor and how the thing, you know, feels when you're working in a pair. And some of the things like the goals, like documentation and stuff like that, it's kind of, I just showed you rack as an example for, you know, I would say, you know, to me that's embodies simplicity. You know, you just have to do a git clone and start reading reading the code. So if I have time, I can do all that. I think you have a good point, but in the interest of time, I actually want to see how much material I can get through, and we can actually go back and look at some code samples really to illustrate those concepts.
Right, so if we do some of the concepts, if you have examples, it would be easier to
understand. I think,
right,
yeah, it's very abstract.
For example, you mentioned data, duplicate data.
Code duplication, everybody knows. 100% everybody can do. Data duplication,
so
yes.
How do you test it?
Like for instance, I can give you an example. For instance, you're using, let's say, one of the recent project I was working on, okay, they were using -1 for a record, a primary key, okay. They're using -1 or 0 because what is the significance of -1 or 0? The record is not there. When the record is not found, I want the behavioral system to be this way, versus when it does find, it does something else. So if you just use the magic number like -1 and 0 in your code everywhere, it's all over the place, and you would rather have a constant defined as illegal primary key equals -1. That's it. You just say illegal primary key. It signifies, okay, that's what the meaning you're attaching to it, to that thing, 0 or -1.
I think
what I meant is, if you could show us an example how you use TDD to find such problems. I understand magic numbers.
Because now you've seen the problem.
I see the problem. How do you test it?
Yeah.
Right, that's what I mean.
Yeah.
That we have to work on a problem to see, you know. The test, see, when you start writing one test, 2, 3, and then once you reach the third test, you start recognizing certain duplication. See, the cleanup code, make it right, start it right, write a failing test, make it pass, and then you refactor. Refactor is the state when you actually recognize the duplication. You clean up, your time for a cleanup. So you have to actually, the best way to actually do it. That's why I just want to, give you the exercise, and once you start identifying what the duplication are, you are going to be cleaning up those things, you know. So you have to actually do it in order to.
So it's not something that you could detect through TDD test cases, but
yes.
more like something that you find out during refactoring?
Yes, you can actually see how it emerges. You know, you're going to look for the pattern that as it emerges as you code. So let's work on that factorial or something. If you guys want to start working on it right now, It's only going to take like half an hour. Okay? It's up to you guys. So, the next section is the basics of testing. This is again divided into subsections, which is we will see some terminology before we can discuss, how to write a test and all that. We need to look at some testing specific terminology, and then we will see some bad tests. Either the existing code base, if you know, okay, these are the bad tests, you'll be able to recognize, okay, this is a bad test. And if you know how to write a good test, then you know, okay, what is it that you can aim, how high you can aim for, right? And then the stubs and marks, which is pretty, almost like an hour worth of material on stubs and marks, which is, I think, is the most important part of today's session. So the first thing is terminology. To give you an analogy, before I even dive into this, explaining what the terminology is, it's just a very simple. I come from an electronics background, so it's just a breadboard, and you have LED, and you have a resistor. It's just the Ohm's law. You have a certain specified voltage you provide this circuit, and you have a specified resistor, and you expect the output is green, right? The LED is lighting up. So you have input, which is a known input. You get a known output. Okay, you have a direct input, direct output. That's what you actually did in your Fibonacci exercise. You gave a direct input, and you got a direct output. You were able to observe the input that you sent, and you were able to observe what was coming out of the system. Okay, this is direct input, direct output. So the control point is wherever we are providing this input. Okay, those are all the control points. Control point can be either observation point. Observation point is where we are observing what's happening, what's returning. In this case, you can see that LED is obviously it's visible. So that's the observation point. So I will time these things to the testing terminology. Few slides from now, there will be a diagram. So we saw direct input, direct output. Sometimes you have like a complex circuit like this. It's not a simple, Ohm's law kind of a thing. This is what your code is actually going to be. In a real world, it's going to be really complex, right? In this, you have like a really complex integrated circuit. You can't really, it's not like a LED where you can, with a visible eye, you cannot see anything. But it has, if you have this probe, if you have this thing in your observation point, you can see it's creating the sinusoidal waveform. But you can't see it. You need a special observation thing in order to see it, capture it, and view a particular thing. Okay, that's like an indirect output. That's what is called as an indirect output. You need an observation point in order to see that indirect output. So for our software equivalent, it would be like somebody signs up. I need to send an activation email. Somebody actually registers. I need to send a messaging, put a message in a messaging queue, for instance. It's asynchronous thing. You cannot observe it. It's not returning your result set, right? It's indirect output, similar to this, okay? So direct input, we already saw. That's the incoming thing, which is incoming message. You're sending message to somebody with a known input, okay? So here is the indirect input I'm actually showing in this diagram right here. You have, I'll be going over this thing in more detail as I cover once I go through the terminology, I'll be covering this canonical test structure, how it is structured, and I will explain what it is. For now, I just want you to observe. In the exercise space, I'm just sending a message to whatever I'm testing. SUT is a system under test, whatever I'm testing. It could be an object, but just a method in an object, okay? See, it has dependency on someone else. Objects always collaborate with other objects in order to accomplish something, some task, right? So, but it also requires some indirect input for somebody else because it collaborates with the other guy, dependent on component, some other object. So that's providing certain input, and it needs this input in order to do its job. So this is the indirect input. This is like drawn like this because it's invisible to you. That's why it's indirect input. It's not, you cannot directly do a put as, or you cannot do anything. Okay. So direct output, we already saw the result. I called a stateless thing, like Fibonacci thing. It returned me a result. It gave me an integer, right? That is a direct output. So indirect output, like one of the things I mentioned was somebody signs up, I sign up, user sign up. Okay, this is the sign up module. It needs to send something to the email, action mailer. This is another component. It's basically a framework. It needs to send an email, but we cannot see an email that has been sent to somebody else who just signed up. It's not coming to our inbox. We cannot observe it. That's why it's called indirect output. That's why it's within this. It's like a hidden here. It's invisible. Okay. So it's indirect output. How we test them, I will come back to it later. We will revisit them. Okay. Just now, get the distinction between direct input, direct output, indirect input, indirect output. There are 4 different things you need to be aware of. Okay. Why it is indirect? We cannot use. You cannot see the indirect input and indirect output. Whereas the direct input and direct output, you can see them. Okay. It's coming to you as a result of some particular operation. So in this case, like again, this is an object. All the incoming messages. If it's a part of the public API, all these incoming messages, someone else is a client for this object. And it depends on a particular, some other object dependent on a component, or some other package, module, whatever you want to call it. It's putting some message into a message queue. It's putting something into the database, inserting a record in the database when somebody signs up. He needs to somebody purchases something. You want to actually put the job in the queue and process it later. Because anything that takes a long time, you want asynchronously you want to handle certain cases because you want to immediately return back to the customer. You want your apps to be responsive. Okay. So all these things are indirect output. Okay. It's going to a messaging queue. It's going to a database. These are the incoming message for this guy, or these are the outgoing messages for these guys. Okay. So here everything is put together. You have set up the initialize SUT. You put the system under a certain state, known state, and you provide direct inputs through the control points. Okay, and you have at the exercise phase, you call. In your case, it's Fibonacci dot. You called a number or sequence or something. That's when you actually invoke the method that returned a value. With return value, you got some value back, and you verified. You verified it using an assertion. Okay, result should equal 0, and you check the state. Okay. Through the observation points, you were observing what the direct outputs were from the system which was under test, and you verified it. Okay. Teardown is I'll actually go through the 4 steps in detail and say when it's applicable or not later. Okay. For now, I just want you to focus on the terminology. So these are all visible. See this invisible thing. So it depends on something else. Somebody else needs to provide. I have code sample coming in. Okay. I'll show you how this indirect output, indirect input actually looks in the code to you, okay? I know it makes it more concrete if you have a code example. Just bear with me, just focus on the terminology for now, okay? So indirect output is provided by the dependent on component. Indirect output we already saw, it could be messaging, something you're like going on behind the scenes, you cannot really observe, okay? So just the basic terminology, introduction to basic terminology. Now we are going to see how to write tests. Okay. So this is divided into 4 subsections. I will show you the canonical test structure, 4-phase test. So we'll see the testing techniques, the messages, and some testing guidelines. Okay. Like Gabriel said, all these guidelines are just the guidelines to begin with. You can violate them if you can justify them. You can reason them and it makes sense to another developer sitting next to you. And he says, okay, sounds good. Okay, before I even go into those subsections, I want to set the context right here first, okay? This guy, who is this guy? Brian Kernighan. Anyone?
C.
Yes, he's a very smart fellow. Okay, so he had something really important to say about this. Okay, remember this. You think you're really smart and you write the cleverest code you can write, by definition, you're not qualified to debug it. Okay? And it's coming from Brian Kernighan. So keep the test very, very simple. The reason we have the test is basically because we want to avoid spending days in debugging, okay? So we want to keep the test really simple. We don't want to be clever. What should I do then? Only focus on what, not how. How is all about implementation. What is what focuses on specifying the behavior of the system, okay? You always want to focus on what, not how. How is all about implementation. So when you focus on what and you don't do any of those how, your code is going to be declarative. Okay, by definition, this is what declarative means. If you look at Rails code, it has the has and belongs to, has many. Those are all declarative. Just specify. Specify the relationship, right? ER modeling, one to many, many to many. You specify. It's declarative code. So declarative is all about the what, okay? Imperative is the exact opposite. It's all about the how. Imperative is a different kind of programming paradigm. We want to be on this side. So we had this keyword specify in the RSpec. I'm going to the dictionary definition of specify. I'll just throw this term, specify behavior. What does this specify actually mean? You state a requirement clearly and precisely. That's what it is. When you want to specify a behavior, there is no ambiguity. It has to be clear and it has to be precise. And when you're writing a test, you focus on one thing and one thing at a time. Every test is focused on doing one little thing at a time. Okay. So now let's look at the first subsection, which is the 4-phase test. So 4-phase, we have like 1, 2, 3, 4 of them. Setup is the step, phase 1. Setup is when you actually create some objects. You put the system into a known state, okay, by creating objects and all that. It's also called as test context. The system needs to be in this state before you can actually invoke anything on it. Before you exercise a method, you're doing something to you're going to invoke something to them first.
Question. Often when we're testing, we'll want to specify what I call a happy path and also certain pathological cases.
Yes.
Do you recommend, because often we'll have certain tests that will set up, not in the setup method, the pathological case. Do you recommend separating those into separate test cases?
Very good question. I can actually say, to some extent, you want isolation between tests. Okay. Mm-hmm. When you have the alternative scenarios, like the pathological cases, it depends how much of the test context you're going to customize. Okay. I always want to be very clear in my tests. Okay. What is it specific that I'm focusing on? Okay. And if you can have a generic before that handles almost all of the cases, I would override in that specific pathological case. Whatever I'm overriding, this thing has to communicate intent. Pathological case number 1 is what I'm testing. Okay, I'm making the test state very, very specific. If you make it within the same test case, then it's very clear to anybody to reading this thing. Oh, I see the relationship between the test context and the behavior I'm going to exercise, invoke on it. Okay, clarity. Okay, clarity is I would have that clarity, being able to override in your specific things, regular things, all the different things to customize according to what you're testing. So your intention is very clear. Okay, does that answer your question?
So you're saying have a context, and then before, let's say, you want to have certain attributes, just assign it to them.
Like let's give a concrete example. Like let's say we have a valid user. valid first name, last name, email address, everything is valid. Pathological case number 1. This guy is entering email which is invalid. I actually have a user, valid user. If I'm using a factory girl, I can actually override email to a invalid email alone and check that your actually validation actually catches that invalid mail validation error. Okay, I override factory.create email is I provide invalid email. Everything, all other attributes is valid because the factory girl actually provides the default values which I already specified in the factories.rb. Okay. So in the case, just by looking at providing an invalid email, when I'm reading the code, I know exactly, I'm testing the pathological case of, what happens if it's not a well-formed email address, right? That's what I was trying to get at. You're customizing the test context according to that specific test you're actually testing.
So did you mean that within a context, write the happy and non-happy test?
Very very good question. Actually, the thing you brought up is like we have a happy path, golden scenario, that's applicable to in most of the cases, right? I want to have it in my factories.rb, the happy path, valid object with all valid attributes. I will override, sometimes the last name cannot be blank. I will override only that particular thing. That's relevant to that particular test. Is it clear?
Yeah.
Okay. So that's how we customize the your test context depending on what test you're doing, and then you can exercise. Verification state is where you do result dot should equal. You have a lot of matchers. Okay. I will give a crash course of RSpec matchers. Most of the time you're going to be encountering these things, and if you need something else, you can always refer the documentation. Okay. And the teardown is for unit tests. You don't really have teardown. Each test should be isolated. At the end of the test, you need to revert back the state to before you had the test running. Okay. So in unit test, most of the time you will not have this phase because. But unit test, by definition, you should not be hitting a database, you should not be going to a file system, you should not be going to any of the external resources, you should not be going over the network, for instance, right? It should be self-contained. If you're going over the network and doing all that, it becomes an integration test, it's not a unit test anymore, okay? In that case, you need to tear down the network connection, you need to release the resources, file system resources, anything you're hanging on in your tear down part of it, okay? So whatever setup email, you establish the network connection, but you need to release them here. Establish the database connection, but you have to release them here. Whatever database web service calls you are setting up connections, you have to release all those resources here. So the next test, when it runs, it gets a clean state, okay? And it's going to actually do a setup for its according, whatever thing it's testing, it's going to set up its own test context. This way, one test context will not affect the other test context. The dependencies between tests will not be there, and you can run any of the tests in any order you want. Okay, there is no dependency on the order in which you run the test. We want isolation, independent tests. Okay, and then now I said in unit tests you don't have a tear down. It degenerates to this 3 A's. It's also called 3 A's. First step, setup page, you arrange, you create some objects, do something, you put a system under a certain state, you act on it. This is where the exercise part was in the previous slide. And then you assert. This is the verification. A. This is also called 3 A's. Okay. And if you look at the Cucumber, same thing. It's at the macro level. Given when then. Given the system is under this state, given all these assumptions are valid, when I do something to the system, this is when I am acting, exercising the system. Then something happens to the behavior I want to verify. This is where I want to assert the behavior here, so I can verify. Okay, this is at a macro level. That's a customer test. Business intent is what is revealed here. And this is a variation of the canonical 4-test structure, where you have the setup, but if you see this, before exercise, you have a expect. You're setting expectations on a certain thing. marks. I'll be covering it later. I just want you to get a variation flavor. It's an alternative thing. We don't see verify at all, because when you set expectation, there is an implicit checking at the end of the test. The framework actually does the verification for you because you have made the expectation here.
What is this? What is this?
This is when you be using marks. This is
Yeah, because I've seen it like should receive.
Yes,
five
should,
first,
yes.
And then you call them.
yes.
later?
This is should receive.
Okay.
That's how you are setting expectations. Outgoing message. The terminology is indirect output is what you are setting here. You're saying this is something I cannot see. I cannot see it. I want you to verify for me. That's what you're saying essentially. RSpec will verify if the call is made, it passes. If it doesn't, it fails. Okay. So I already threw in this term called SUT, but I want to define what this SUT is. Based on the context, SUT can keep on changing. Okay. SUT is system under test. In this case, when I'm writing a unit test, this SUT is just an object, it's just a message. I'm sending a message to this thing, I'm testing it. I'm writing another unit test, it's testing a different object, but it has a dependency on another object here. It uses something else, right? But I'm testing them in isolation, okay? But when it comes to the entire thing as one unit, it's one component, I have a component test, okay? That is going to exercise the entire thing as a component. Okay, to answer some of the questions that you had, for instance, I test these two in isolation. When I write a component test, I don't really mark any of this thing between. I let the real interaction go on because I want to integrate them. This component test is more like a mini integration test for these objects here. It's more like this you can consider as like an active record. This as your custom thing which is extending from your active record. You have a dependency basically. And when you write Rails unit test, it's going to hit the database. It's like a mini component test in this case, to give a concrete example. Okay. So you have a component, a cluster of objects within the component. You're testing them. Again, you have a component test 2, another component. You have a cluster of objects inside of that you're only focused on testing that. Maybe it's like the pricing module, or it's like an external API call going to authorize.net or something. It all belongs together. Okay, and application level, the entire thing is a black box. The entire application is a black box. This would be what in our case? For instance, if you are considering our Ruby project, this entire application is a black box. Entire application is the system under test. This was a system under test, this was a system under test, component became a system under test, cluster of components has become your entire application. This is basically your cucumber. This is a black box. What are the events that the user can do? User can purchase, he can put some product in the shopping cart. User can check out. Is all the user level events going into the system, and the entire system is actually doing something as a black box, and it's allowing user to accomplish their business goal, right? Every use case actor, everybody has their own intention when they're using the system, right? So you don't really care what's going on inside. You only care about what's going through this, what's coming out of this. It's a black box because you don't care what the state is inside the system of your application. Okay, we just saw what is the system under test. Here is some of the beginner's mistake. Actually, even I have made it. You actually have this system under test, which is just object right here in green. But when you have a fake object, if you replace the entire system under test, you are not testing anything anymore. You're fake. You can program the fake. I have a code example for this thing I can show you. Right here. Don't mark yourself out. This should illustrate tautology, because here I am creating that stub. Okay? The object called Paul, and his age method is going to return an integer for me. Okay? And then I'm just saying, asserting Paul age should equal 18. Yes, this will always pass. because that's what the stub is programmed to do. You have replaced, if you're going to test a person object, and if you can respond to the age, where is the person object? You have replaced the entire person object with a stub. So whatever you're doing here, it's meaningless actually. So this is one of the beginner's typical mistake. And right now I'm showing a very, very explicit example, but in your test, if you're using partial marks, if you have read RSpec book, you can use partial marks. And some of the things are very subtle. And you might have a little bit of overlap. And because of that overlap, you're not really testing anything. You're just stubbing or marking is doing some your stuff, and you think, okay, you have a false sense of confidence. So you have to be very careful when you're using partial marks, okay? And use them very sparingly if you do use them, okay? And here is another beginner's mistake. You have SUT1, SUT2. I showed you the diagram where they were all like independent of each other. Now, in reality, you have some overlap. SUT1 and SUT2 has overlap here, which means you have tests for object 1, tests for object 2. You have some assertions that is common across both these two tests, which mean you have duplication basically. You specify once and once only. You don't specify multiple times and multiple times the same thing. You test the one thing and one thing once only. That's it. There should be no overlapping tests. You're basically having adding unnecessary burden of maintaining a test in order to, just to get a false sense of confidence. No. This may not be obvious because it's across two different modules. It's in two different objects, two different packages. So finding this overlap is not that easy actually. And different developers are working, and this could happen without even, it happens unintentionally sometimes, okay? So we already saw the canonical test structure, the four steps on it: setup, exercise, verify, tear down, and we saw the degenerate where we had only 3 A's. 3 A's are what? Arrange, act, assert, right? We don't have tear down because unit test you should not be really hitting anything, any external resources. And then we saw the variation of it when you're using a mock, right? You have a setup, you have expect, and then you have exercise. There is no verify as such. It's implicit verify. RSpec does it implicitly, okay? And we saw all those 4 different things, and then what you could, beginner's mistakes that you might make. What is the system under test? What happens when you have overlapping test? What happens when you replace the entire SUT with stub? You're not testing anything anymore, okay? Now we're ready to look into testing, some testing techniques. Okay, this is what you actually did in the example Fibonacci thing you wrote. You hard-coded everything. You were just faking it. It was not a real implementation. You knew it. It's not going to work for all cases. But you still did it. Why? Fake it till you make it allows you to actually take that one little step. You had problems with class not found, all the syntax errors, everything. You got past that stage. Then you wrote another second test that was also hard-coded, third test hard-coded, and then eventually you had to replace all the constants with variables, with abstract solution, right? Because that's the only thing which can handle any arbitrary number and can give you a valid answer, not the hard-coded ones, right? You can extend that solution to any number of any integer argument. Fake it till you make it is used when your domain is unfamiliar, you don't know how to approach the problem, but you want to take baby steps, small steps, one at a time, and you gradually converge towards a abstract solution. Okay, it gives you that momentum. You start generating momentum. You learn more about the domain. You get more comfortable. You learn more about the system. It's a learning process. Okay. As you learn more, you start to write progressively more difficult tests, okay? And triangulate. This is a mathematical term. You measure the ship from one point. From there you measure what the angle is, and then again you go to another place and you measure the angle again, and then you plug it into a formula and you find out, okay, what is the distance of this ship from a given particular point. It comes from mathematical term. When applied to TDD, I gave you examples, like I gave you a table. Okay, 0 is 0, 1 is 1, 2 is 1, 3 is 0 plus 1 or 2. You just kept on, I gave you that example. Each example, if you are going to use triangular to solve the problem, you take the first row and you have executable example. Second one, executable example. Third one, executable example. You gradually make the test drive the abstraction out of the code. Okay? You handle the boundary conditions. Okay, boundary condition. Okay, I got past some of the things I was having problems. I'm now more comfortable handling the abstract thing, and eventually you solve the actual problem. You triangulate. Okay, you're coming from all this. You're kind of going from different points. You're measuring different angles. You're having different boundary conditions, and eventually you're like going from all the difference on the problem domain. You eventually have enough confidence in solving the actual problem. Okay. And the right solution, if you're so familiar with factorial or Fibonacci, you could just type it in the obvious implementation. That's the right solution. Obvious thing is, okay, I already know this. I'm familiar with it. You just type it in. That's the right solution. Nobody says you always have to fake it till you make it. TDD allows you to take small steps. That doesn't mean you always need to take baby steps. If you are confident, if you're familiar with the problem domain, you can take a much bigger, longer step if you need to, okay? As long as you get to the green quickly, that's our goal. Okay. Those three techniques were at the smaller writing the test level. Now this is from the entire system level, working, considering the 4-phase. If considering, we saw the 4-phase: setup, exercise, verify, and he had like tear down, right? 3 things. Okay, working backward is exactly, you're not going from 1 to 3, you're going from 3 to 1. Okay. For instance, I'm writing a calculator. For instance, 5 plus 5 is 10. Okay, I know it's going to be 10. Manually, that's what I'm checking. But how can you automate that manual checking process? That's what is called an assertion, right? Okay, 5 plus 5 is 10. So you write the assertion. That's the statement has to be true. That is the post condition state of the system. That has to be true in order for my test to pass. You start with the assertion, okay, that needs to be true, and then you work your way backwards. Sometimes this is easier to go backwards. Write the assertion first, then you exercise the system, and then you provide the context it requires so that okay, you can exercise the actual object under test. This is outside in BDD, inside out with the classic TDD. Outside in, what does outside in look like? You start, why is it called outside in? You start from the outside. You always start from the user's perspective, right? You write a Cucumber test or something. How does the user interact with your system? They actually click on add to a cart, right? The events are coming in externally. And how is your system going to respond to those events, right? It's coming in, you have a system under test, you have SUT that's actually have interaction with another SUT and so on. This is the one which is independent of everybody else. And at each of this layer, you're using a lot of fake objects, test double, stand-ins for these guys, actual thing. In order either to make the test run faster, if it's like unit test, you actually use the test double. If it's a customer level test, you use the actual object. So it will make your test run faster if it's a unit testing thing. So SUT actually uses the test double. In production, it's going to use the real object. And in the customer integration level test, it's going to use the real object SUT, okay? All the test is coming from outside in, the events coming in, and then gradually exercise the entire layer, each layer in the stack of your system, okay? So you outside in, you start from here. Number 1, write a failing acceptance test. Number 2, does the acceptance test pass? If it passes, the feature already exists. You're done. You don't have to do anything. If it fails, you drop down to the unit testing level, you write a failing unit test. Okay? And then you make the test pass. And then you refactor. This thing we already discussed in detail in the previous session. The only thing you notice is the outer section, outer circle. Outside in, we are coming outside in. We're starting with the events coming in from the user's perspective. That's going to drive the entire thing. And if you keep on doing this inner circle, many of these circles, eventually it's going to make the outermost thing pass. Okay? That's how we know you're done, because that's the acceptance criteria you have set. Okay?
So here acceptance, you mean like behavior test?
Yes, acceptance. This is the cucumber test. Cucumber, higher level. This is the outside in, the BDD. When you say I'm do BDD, this is the outside in development. Because one of the things you remember, when you're running the cucumber, they say, okay, you exactly know what to do next, because we are giving you the steps. These are the pending example. This is what you do next to get your test working. Even when then, okay, go ahead and do this. And then eventually drop into the inner circle and you do unit testing. Right? So
What is BDD versus TDD? Like in
BDD,
they're writing tests, right?
okay, in TDD, remember I discussed about the classic TDD? TDD began just as a TDD, like Ken Beck, what he does, when he's coding, he always uses real objects. If you see him coding, there's a Pragmatic Programmer's book, screencast by Ken Beck. He even uses an actual server when he's interacting. Actual server is running on his machine when he's coding. Okay, he does not use stubs. He does not use any marks. Nothing. Use real objects. He uses inside-out development, not outside-in. It's inside-out. Starts with the domain model. Slowly, your entire model, one of your business object is depending on some other business object. Eventually, it goes and depends on some business object. It's not dependent on anybody. Eventually, it goes to the next layer. After business layer, you have some other interfacing layer. If you have a messaging system, you have a messaging adapter. Or you have ORM adapter layer. If you have ORM going to a relational database, you have a web service, right? He grows and he goes across layers, and eventually the entire system is covered. It goes inside out. Why we start with the code, okay? So that's what inside out is all about. This is the TDD. TDD, BDD. This is the TDD, classic TDD. This is what they do. Outside in, that's the BDD guys, what they talk about, when they say BDD, that's what they mean. In TDD, you start with a test, they have a SUT, you start with the test this thing. See, you don't see testable anything here. You don't see anything here. It's all real objects. This guy is independent of everybody else. Obviously, you will start with this, testing an independent component object by itself. Now I have this guy ready. I can test this guy who is depending on him, and I'll just let him use the real object, and so on. I gradually do the entire cluster of objects. Once I test, I'm gradually going to go to the next layer to the almost boundary level objects, which is going to be interacting with the UI, messaging queue, anything, web service, and then it's going to hit the external systems. It's going to cross layers, right? So we saw the testing techniques in the sense, what are the things? Triangulate, fake it till you make it, obvious implementation. That's like a very, very minute level where you're like typing in your code. And you have several options of which one to pick based on, how confident you feel about the problem domain and how confident you are familiar with that solution. What is that alternative solution? Am I comfortable with this? Whether it's going to work or not, And then we also saw from an architecture system level view of, okay, what's the outside in? What is inside out? Do different development methodologies that also allows you to focus when you're using, acceptance criteria to drive the entire thing, testing the entire system versus doing inside out where the classic TDD guys like Ken Beck use, okay? The next section is going to be on messages. Everything actually can be boiled down to just messages being sent from one object to the next. Okay. and either it's an incoming message to an object, it's an outgoing message to an object, and it's a message sent to itself. So what is the message that the object sends to itself? What does it mean, sending a message to self? I'll come back to that thing again. Right now, I just want to focus on these two objects right here. We have all this variable state of an object encapsulated. Okay? You can only go through this public API. There are methods available that acts upon this state and provide certain services to other objects. Okay? And there is another object, and this object cannot do everything by itself. It needs to collaborate with other objects. It has to send messages to other objects to, do its task and return some result, or so it has some indirect output or something, right? You follow the good OO principle. You encapsulate. You follow the encapsulation. It's abstraction, all those things. Well-designed objects. If you have all the well-designed objects, you also need to make sure the communication between those objects are also well-designed. Like, for instance, you always depend on something which is more stable than you are, abstract. Don't depend on concretions like solid principles and all those things, right? So you cannot just have one or two objects. Basically, your domain model will be having multiple objects. It's a web of collaborating objects. It's a graph of objects, right? This guy is independent of everybody else. Everybody else uses the services provided by this guy. And this guy services are used by these two guys. And this guy is eventually using this guy, who internally uses all this. So you have all these different communication paths. Look at all these communications going from one object to the other. In a well-designed system, you'll be very careful how you design this messaging between systems. If you see some Rails code projects, you'll actually have this. It's like a violation of law of Demeter. Foo dot B dot C dot A dot. You just keep on chaining them to the. It's a train wreck basically. In a well-defined interfaces, if you have well-defined interfaces, they provide some services. That's all you need to know. The public API, you just use it. That's it. Don't just keep on grabbing data and keep on chaining calls forever, unless you have very good reason to do so, right? So if you design those services provided by the objects properly, you will think about what is this interface that I need to provide. I want to fulfill my responsibility as some object B here that does not exist yet. Maybe Karen is working on it right now, but I need to write my object A. I cannot wait till she is done. We are working in parallel, right? So I can replace it with mock. As long as we have agreed upon a well-defined interface, okay, we have agreed upon this thing, okay? She has told me these are the arguments I'm going to pass through, and she's going to give me this result set, okay? I only program to that interface. The mock is basically going to comply to that interface. When she is done, I can use the real object. The integration test has to use the real object. It can't really use a mocks, right? When you write a customer test, it has to integrate all of the layers together, right? So it's a way to discover the interfaces. I want to discover this interface. What is the role that this object plays? And then I need another service from another object. I gradually discover all the different interfaces I need. Okay, Gabriel is working on some other thing I need from him also, so I have another contract with another team. And I start using another mock to replace Gabriel's module. And so on. So you have all these different interfaces. These are all the web of objects collaborating through roles. Not just interfaces, you want to find the roles that objects play. Okay? The main point of using roles is basically it allows you to compose objects in different way. Okay? Let's say I have like a person object, Person object can play the role of a student, it can play the role of a son, daughter, all these different things. But you're playing a different role. As a student, I have certain set of responsibilities. Study, pay attention, all these things. Those are all methods. Responsibilities, those are all methods played by that particular role. And if I don't attach it to a person object, I can take that particular role, student role, and I can give it to a dog object. It can be a student now. Now, without even actually changing the system, I can pass in a dog object to the system. I compose the runtime object composition will be different. Behavior will change. Because of the duck typing, everything will just work. You need very minimal, even if you need to make any changes, very minimal changes in the code is required. Okay? So CRC, in XP we use CRC cards for doing design. There is no UML modeling, all that thing. It's a very agile way of actually designing it. Here is a game engine. This is the candidate class. So these are all its. The column on the left is all the responsibilities of this candidate class. It displays game state. This is a role. Again, this is a responsibility. This is the role actually which collaborates with this game engine in order to accomplish this particular responsibility. Okay, resolves collisions, all these things. So this is the candidate class, and these are its responsibilities, and these are its collaborators. Okay, instead of CRC class responsibility collaborators, you have to start thinking in terms of in terms of roles, responsibilities, and collaborators. A renderer, it could be just a role. Animator is just a role. Collision detector is just a role. This way I can actually swap different implementation of collision detectors. I can have a fake collision detector where I don't really want to incur the expenses, running a long running test. I can actually have a fake animator and it's just not really doing a real animation, it's just faking something. Makes my test run faster. Okay? So you're basically designing for testability. You can plug in different things, you can combine different objects in a different way to accomplish, customize the behavior of the system. So if you think about this, Unix is based on the same principle. There you have pipes. You have CAD, you have LS, you have piping where you can redirect the output to some file. You can use those small utilities that's focused on just doing one thing, but when you chain them all together, they accomplish a much bigger task. We want to do the same thing in object-oriented programming. We want each object to be focused and very cohesive and highly cohesive and loosely coupled. So like if it's loosely coupled, I can combine them just like Unix chaining together. I can combine these objects in different combination and I can accomplish, I can satisfy a new requirement that I didn't really think of when I actually wrote this code. But tomorrow's changes that's coming in down the pipeline, I can actually satisfy the requirement using existing objects. I can reuse them in different contexts. Okay. So let's consider, we have our graph of objects. Let's just assume we have all these communications. It's not like half-assedly going to each and everything and all this it's like a spaghetti. It's well-defined, well-designed, services. Each object provides services. Let's just focus only on this guy. See what's happening. If I want to test this guy in isolation, I have some services being used by this guy. I have some outgoing messages. I have two guys coming in. In order to test this in isolation, I have to actually, replace this entire thing. Actual environment with the environment where it's going to actually resemble as if these guys are providing. If I need something from some other object, I'm going to replace those guys with something which is going to be like a fake. Okay, that's going to run faster in actual test environment. In the actual production environment, it's going to use the real objects though. Okay, so if I just consider one object, I have incoming messages, I have outgoing messages, and I have messages sent to me itself. Okay? So we saw indirect input, direct input, indirect output, direct output, and all the different combinations. What is this message, the object that's sending a message to itself actually mean? If it's an incoming message, I provide some services to others. It's in my public API. Okay? Everybody can see this. It's a well-published API. All these outgoing things are invisible thing. I may be depending on some other components result that's going to come back. Like for instance, if this is a shopping cart, let's take a concrete example. Shopping cart, and somebody customer just selected this in the shopping cart. They put a product into it. They said add, and they provided a parameter called as, okay, I want to purchase this book, and they said I want one book in this. Okay, one book is in here. Okay, eventually they say I want to check out to the shopping cart, but the shopping cart in the checkout, what it needs to show them is how many books did you put it in your shopping cart, what is the price, what is the quantity. It also needs to show how much you're going to pay for the shipping and calculating, right? Shipping and handling. But shopping cart that's not the job of the shopping cart to do the tax calculating. Tax calculating is somebody else is going to do it. That's the dependent on component. Tax calculation needs to know what is your state, what is the weight of the item that's going to be shipped, right? So I can calculate based on that geographical location. I can give you what the tax calculation is. I can just give you, okay, this is the amount. What is the total amount you want to charge tax for this state, this weight? Here is your tax. Somebody else is going to give. So this guy is going to ask, okay, this is my total weight. This is this is the state where this customer belongs to. Please give me the tax. He's going to ask him. This is the indirect input that it requires in order to go and actually provide the line item display that the users can see from the browser. Okay, that's another concrete example of a indirect input required by this guy in order to fulfill his public API services. He is providing an API. So this way, I can actually stub out the tax calculation. I don't really need to go to the database to find the just geographical location. 6% is the rate on which I need to calculate tax. I can actually fake the entire thing. So my test will run faster. So we already saw the test. When you actually write a test and you're going to actually test a particular object, it's going to depend on certain services or something else. If it's under parallel development, some other team is working on it, or you don't even know that even exists, it doesn't exist yet, or somebody's working, but you need them. What are this? You need to have your test written for your thing that you're working on. That's when you actually replace them with marks, basically. Okay, those things will also be you have more control over it. As long as you have different interface, you can actually complete writing the text for your particular module. Okay, so any questions on the messaging thing that we have already seen before we move on to the testing guidelines? You always use the public API first. Use the front door first. The public API is also called as the front door.
Would you be giving us example with interacting with third-party service like HTTP doing something and then taking that? Could you show us an example?
Example for
Interacting with third-party service. Let's say you're doing like HTTP or like
that. I have a diagram for that towards the end of the thing. Okay. I have a diagram which actually goes over it.
or anything with vector source instead of vector record.
Yes, anything with deals with external resources.
Yeah.
Okay, I'll tell you whether you need to stub or a mark, when you actually have to integrate, how we will do it, all those.
So summary of this section was, if you are having any third-party interaction, just mark that, right?
No, don't mark. Marking is all about. I'll coming to the mark with this entire section on mark. You don't mark a third-party library because you cannot drive the design of a third-party library. If you have authorized.net, PayPal API, you cannot mark them because you have no control over what they are doing. Okay, but what you can do, you can stop them. You have more control over it in your unit test. In your unit test, you will stop them. Okay, but for the integration test, you have to actually write a test which is going to hit if it's a PayPal, it's going to hit the test sandbox actually, just to make sure your system can interact with their external API as of now. Okay. When somebody comes, if I go into a project, somebody gives me a Braintree, say, okay, here is the Braintree API. I don't know how it works. I want to learn the API. So write tests to make sure your understanding of how that API works is valid. Once you have the test that's specific to that version of Braintree, where Braintree 1.0 I have learning tests, okay? That's more like integration tests. What is the value of having that? When Braintree comes up with version 2.0, if some of my tests fail, I need to fix them, upgrade them, because my code eventually will fail because it's dependent on those assumptions, right? Whatever changes I make for that learning test for that API, I need to make those changes for my dependent objects, basically that particular layer. You actually need to have a very thin layer. Your domain model, you'll have a very thin layer of adapter that's having well-defined interface that you have control over, that you can mark, but the thin adapter will adapt your domain model to the external API calls. Okay, so this way you insulate the changes from the third-party changes. They have their own release cycle. I don't want my deployment to be impacted by somebody else's schedule, right? I want to have more control over it. That's why I isolate it. This is like an anti-corruption layer. This way I decide when I want to upgrade Braintree. When I run all these integration tests, if all of them pass, oh, no problem, it's backward compatible. Just because he says in the documentation, README, it's a backward compatible, I cannot rely on it because I don't want to risk my system blowing up, customer not being able to purchase items on the site because third party, I cannot blame it on them, right? So I need to have that testing that needs to give me the confidence. Okay, if I upgrade this, if all of the test passes, I can guarantee, okay, none of the changes will impact our code base and we can go ahead with the upgrade process. So you can pinpoint, okay, what is going to be the impact of changes? Instead of saying, I don't know, maybe we'll upgrade and see if everything goes. I don't know what the impact of changes will be because you cannot really determine unless you have a test suite that you can run automatically at your command when you want to run it. Right? Then you can pinpoint, we have like so many tests breaking and some are serious things, we need to really look into it. We cannot really upgrade right now. No, we need to hold off on it. We cannot upgrade right now. You can make the decision, okay? I'll show you that layer and I will be talking about them later.
I'm still confused. So you're saying call the real service and their method?
Your question was how do we deal with the external web service?
Yes.
External webs, you don't mark, you stop them.
Stop them.
You stop them in your unit test, so your unit test will be faster. Because you should not be going over a network in any of your unit tests. You should not hit external resources.
I'm just confused. So what is mark and
Yeah.
Yeah, I'm going to actually have a 60-minute session on stubs and marks, and then it will be a little more clear. We'll revisit the topic, okay? So one of the thing is like challenge is all this material. It's not linear, but I'm trying to gradually build you up to it, so everybody is at the same level. Once I start discussing those things, everybody will understand what I'm talking about, okay? Otherwise, I'll be jumping the gun too soon, which I don't want to do. So, okay, right now, let's look at some testing guidelines. Like Gabriel mentioned, over the lunch, he said, I have violated some of these things. Yes, because it's because you know what you're doing. These are guidelines to get you started. They are there for a reason, but if you have to break them, do them for a valid, sensible reasons, okay? The first one is like don't modify the system under test. So I've seen this thing, a lot of people actually we have a lot of tests, for instance, in one of the projects, and suddenly some tests started breaking. Okay, so what he did was he went into the production code and he put this Rails if Rails env equals test, skip this line of code. So what he did was system under test is basically your production code, and he's changing the behavior of the production code to be different in the test from what is in production. If you start having these kind of conditionals, band-aids in your code, eventually it's going to create more misery than solve any problems for you. Okay, so you have to be very careful when you put all these band-aids in there. But Rails already gives you test mode. You have all access to this thing. You have a test that RB, which is like specific configuration for testing, and you have specific for production, and you have specific for development. So you configure according to environment, but don't change the source code and put band-aids in there because it will cause problems later. Okay. And keep test logic out of production. Basically, yeah, same thing. Band-aids, everything. Don't put like if I'm in Rails and we do this, otherwise do something else, and it's just going to create a lot of problems down the line. Okay, this also kind of we discussed this thing over lunch. Actually, Gabriel was talking about this effort versus responsibility. Commensurate effort versus responsibility. Okay, what does this really mean? It's effortless. The leaf falls down, and just because of gravity, it just comes down. Okay, it's so easy. It's how much effort does it spend? Not much, and it doesn't weigh that much. The thing is, when you have a production code, we have like 4 lines of code. You should not be having like a 10 or 15 lines of test code to test the 4 lines of production code. You're spending so much effort to actually test something as simple as just 4 lines of code. You're doing something wrong. So if you're doing it, do it for valid reasons. Okay, I know I'm breaking it. I'm doing it because I want to increase the communication. I want the communication benefit to be emphasized. That's why I'm writing 4 or 5 tests for just 4 lines of code. That's fine. Or my confidence level in that code is very low. This is very critical part for my revenue. Everything generates because of this purchasing part of the code. Even though it's just 4 lines of code, I don't want my purchasing system to have, I don't want to lose money basically. You have like a lot of things to lose. Monetary wise, you're going to lose a lot, then it makes sense. You always think about, okay, if just one liner, for instance, Rails has like one line, one active support gives you a lot of, very high level APIs. If you can just write one line of code, it makes a lot of things easier. Even test, if you know how to use the right test API, you could just do in one assertion, you can just test everything instead of trying to do like 4 lines of code. Okay, always weigh the effort you're spending on testing something versus what you're actually testing. Okay. So now we will come back to this TDD, BDD, behavior driven development, all these buzzwords. So what you did in the morning exercise is basically a state verification. Okay. What you did was the method was basically a stateless method. You provided some input, you got some result back, you verified that state. Okay, what was the state at the end of that particular call? Was it what I expected? That's what you checked, right? So in the setup, in your case, the setup was creating some object. It was, for some of you created an object and you called that method on it. Some of you had like a class method, so you did not have to create any object. And the exercise phase, you actually called your sequence or number or those things passing in the value. That's when you exercised your Fibonacci, which was under development. You discovered that API. Oh, I want to call this as a number. I want to call this a sequence. Okay. What did you verify? The result that was returned back, that was the direct output from the Fibonacci thing. And you checked the verification. Result should equal 0, 1. You did a state verification. That is the example for state verification. All this thing is grayed out because all these are invisible. You ignore them because it's a direct input, direct output. And Fibonacci is the only method that you were testing. It was not a cluster of objects. Okay. This is state verification, and this differs from behavior verification. What is the behavior verification? You have an object that's calling this object. This internet uses this services from this object as well as this. This guy is sending messages to these two guys. If you see this, these are all like black. I don't care about the state. What is the state? This is the black box. I don't care what is inside this object. My focus is only on the messages that is being sent between objects. In behavior verification, I care only about these messages. Okay? That's what behavior verification is all about. You're not really checking what is the result that's coming out of some method call that you just made. Okay? So here it is. This is what this looks like. You still have the setup phase where you can create the objects you need. Okay? In the exercise phase, you see you invoke certain operation on the SUT. See what happened in the invisible part. You cannot see this thing. These are all like indirect outputs. Behavior. These are all messages going out. Outgoing messages. Initially I showed you everything can be bothered into incoming message, outgoing messages. Outgoing messages, it says dependent on component. Okay? This message could be going to a messaging queue, this message is going to a database, this is going to a web service, right? You want to, if the charger just completed the purchase, you want to charge them. This is the customer's credit card, please charge them, so that goes into a certain queue and gets processed. It's asynchronous. You cannot view it. Confirmation email is sent. Okay, here is a purchase. Email has been sent to the customer. You cannot really see them. But you can assert on those messages and make sure, okay, confirmation email was sent to the customer after the purchase was successful. Okay, the credit card charges was made after successful purchase. I did charge the customer, so I'm not losing money, because it's important for me to charge the customer, especially when I'm going to ship the product, right? So I have to assert on the messages. Okay, he did send the email, should receive confirmation email, something like that. Should receive charge customer authorized.net API that's going to interact with authorized.net API. Okay? That's where you will be using all those assertions, behavior. Okay? So I already talked about the front door. Front door is the public API. Always use the front door, which is always use the public API where you will be doing the calling all the methods. Whether state verification or behavior verification, you will be calling those public APIs. What is this backdoor verification? Backdoor verification is basically you just bypass in the setup method. You directly going to the database in this case. You set up some data here, picture that you need, and then you exercise your system under test. You're not actually dependent on the result that this guy is returning. You're actually bypassing and you're going using the backdoor to verify, oh, okay, is this what I expect this thing to be in state? Sometimes this is actually solve certain problems, but most of the time, state verification and behavior verification is actually covers like 90% of all the cases. Okay, so backdoor is used very few cases, but you still need to know what this is available to you. Okay, and one of the testing guidelines is you should not have any if statements, loops, nothing. I said it has to be so simple that even a interns who is coming in can look at your code and say, oh, okay, I understand this, I get this, right? So how can you, if you cannot have a if statement, then what can you have then in your test? That's where we have guard assertion. Instead of having a if or something, you create a guard. If condition is called a guard. Basically, sometimes if you don't have a guard condition, your program crashes. Maybe you need to add a guard condition. That's what we say, right? So in this case, if it's so important to you and you have to assert, you have to have some kind of if thing, make it as a guard assertion. Okay? So if the built-in API does not give you, just write your own. And make sure you have that library well tested so you can reuse everywhere. And the custom assertion is like some of the domain specific thing. For instance, is not coming out of the general RSpec API, right? Sometimes you have to write your own custom assertions that's applicable for your business domain. Custom assertion or even the domain assertion.
What's an assertion exactly?
Oh, very good question. Assertion, okay, let's take a step back. So assertion is basically, assertion can take any arbitrary expression, okay? We will see a lot of different matches in RSpec, what the assertions look like, okay? What kind of expressions you can have, whether you can just have Boolean expression, whether you can have comparison of, floating point numbers. They're not precise, okay? If you give me like $10.99, and if I have $10.99, if I subtract, but they're still not equal to zero. Yeah. So you have a delta assertion. You have different kind of assertions. It's basically stating post condition. What should be the behavior of the system at the end of the exercise phase?
So in the Fibonacci exercise, it would just basically be
The result
equals
yes,
whatever.
that was assertion. Okay, let's say I'm writing a calculator program. I'm adding two numbers, 5 plus 5. Okay, let's say I'm not even writing a test. How would you manually check the output is right? 5 plus 5 is 10. But you're checking at the output, you're doing a put test or something, right? You're printing to the output console, you're looking, 10, that's correct. See how you manually verified it? Manual verification.
Mm-hmm.
If you automate that manual verification using an API, that's what an assertion is.
Mm-hmm. Okay.
You are asserting the end state of this thing has to be something. It has to be valid. This is the post condition, has to be valid. And if this thing is valid, then I know the test passes.
Mm-hmm.
Otherwise it doesn't. Okay? And you also pass in the messages, and you actually give, this is the expected output, I got this, that's why I failed. You always specify in the message, very big, clear, because otherwise, it will be difficult to find out where actually you need to go in the code and fix it, right? Always see from other guy's perspective of how can I make this diagnostics clear. Custom equality assertion is like you have a person object, let's say. Person object, how can I say TOEFL, right? Person, can I compare the TOEFL person object with the BALA person object? What would I check? What is your social security number? He's not going to give me. So, if the social security number is the same, can I say the person is the same object? For my business domain, I can say that, right? Yeah, it could be possible. So you define your own equality for your business object. Okay, what is equality? We have like equal operator in Ruby. That's what is used in the switch statement. In the switch case, you can use objects. And if those objects you can compare objects, if you define them, if the SSN is the same, I know it's TOEFL. I uniquely identify you. You can come into this country from Bulgaria. It's okay.
6 to 9.
You can come in. Okay, I identify you. I let you in, right?
Yeah.
So, custom equality assertion. If you give two objects, person 1 and person 2, and you have defined your custom equality in your object, triple equals operator, then you can use the custom equality assertion. Okay, you just pass in an object instead of, integer is very equal. You just use equal to compare integers, right? For objects, you have to define your own equality because it has identity, right? So the delta assertion also I kind of mentioned, if you have floating point like 1099, 1099, if you do a minus, it will still be like 0.0001 and it will fail. So you have to say delta, I can 2 digits of 3 digits, it's okay. They're close enough, they're equal. So this is all available in the built-in API. Use the front door first, which is like a public API, before you consider the backdoor way of doing things, because public API is there for a reason, for everybody's consumption, right? And it's public API is well tested. Anything that is private, the messages which is getting to self, I showed you, object sending a message to itself means it's calling its private method. Some other external object can call private method by using send in Ruby, for instance, but you should be careful of touching all the private parts, like private methods as well as the data structure, because it will be changed without notice. It will make your test brittle, basically. Okay. And here is another guideline, which is like verify one condition and one condition only. You should check only one and one thing only. Oh, okay. What if I want to really check 4 different things? Maybe it's with your domain specific assertion. Maybe you need to write your own one-liner thing so you can avoid duplication across all your different tests, right? If this customer or that customer are the same, how would you know? So you define your own customer equality thing, loyalty program or something. You define what it is, those terminology. So you can reuse across. You just make 4 or 5 assertions. If it's keeping repeating everywhere, raise the level of abstraction, make it as a one reusable assertion. So it just becomes like a verify one condition thing. Okay. And then test concerns separately. Like if you're testing the, for instance, UI. Very good example would be like looking at some of the code people write in Rails, right? If you have a controller, for instance, some people do render views inside the controller. Not only they test the controller assigning this thing to objects, they are actually response should have this. Again, that's violating this test concern separately. You should not be doing it. That's not a good practice. Views, if it's a web service and if it's important to test them separately. Controller, just focus only on testing the controller layer. View layer is a different layer. Have a separate test. It's easy for you to maintain. Okay. And keep tests independent of each other, which means you cannot share the test context so much that test context impacts the other tests. That there is a dependence. If you're sharing context, one of the tests fails, and if the other test is depending on the test context left by the previous test, then you have a dependency. You cannot run the test in any order you like. It becomes a sequential kind of a thing, which is not desirable.
I had a question about that, and you mentioned earlier that if something breaks and changes, you should have one test pointing to it.
That is called defect localization.
Right.
If one thing in the production code fails because of one reason, I only want to have one test to fail ideally.
Right. So my question is, if you have like a core class and say it has like a custom identity comparison, and that somehow gets broken because you introduce a new field, lots of other things might break because suddenly 2 objects aren't equal when you'd expect that they would be. Other than setting dependencies and prerequisites in your tests, is there a way to keep one thing breaking when one change breaks? You might have something fundamental break, which could break, in theory, like your entire system. So I've done that where I make a change, I see like 15 or 20, or all the tests go back. It's just like a syntax error. And it'd be really nice to kind of have one thing pointing, saying this really basic thing, instead of having to look through. I'm not sure how to do that other than putting dependencies on tests and saying, my test can't pass if this test doesn't pass it. Is there another way?
It's a very good question, actually. So the concrete example would be, you said it's a customer object?
No, just be shared.
Yeah, I mean, what I was really doing, was it something that represented magic numbers, this mapper we were talking about a bunch. Code that used it broke because I hadn't had it default to returning like a null. It was throwing an exception if you asked it for something. And there wasn't code that happened to test that. So I had like 5 or 7 things break. And then finally I just had to look because I knew I'd changed only one thing. And I was like, what, I bet they're expecting. I looked at the old implementation. I returned null when it wasn't there.
That's a very good point, actually.
But I had 5 tests fail instead of 1, and so I don't know.
That's a very good one. Okay, so to me it seems like what you created is kind of like a value object, if I'm right. It's like a currency, it's like a money object.
Well, I didn't understand what I was replacing because it wasn't fully spec'd in tests. And so it was returning none or null.
Basically,
instead of throwing raising an exception.
That's fine. That's fine. So what you have you read the design by? Are you kind of familiar with the design by contract thing? By Dan Meyer's,
Yeah.
Little bit.
So what is it? Design?
It's object-oriented software construction by Bertrand Meyer.
Bertrand Meyer, yeah.
Okay.
What's the name of it?
Object-oriented software construction by Bertrand Meyer. It's like a huge book anyway. Yeah. It's like a classic. Okay. basically,
Mhm.
you created an object which is kind of like I would say entity. It's like a basic thing that can be reused in lots of different places. It's kind of like a utility thing
Mhm.
that can be reused in
Yeah,
anywhere.
and I broke it.
Yes. Why did you break it? Because you changed the contract.
Right, because I
You
didn't
changed the
understand the
contract.
original contract, which was
Yes.
tested, and so,
The assumption you made was this contract was implicit. Other tests were like depending on the contract,
yeah.
but you changed it.
Exactly.
Right.
It's going to impact all the things which are depending on it.
Right.
How can you prevent this from happening? Okay, I'm going to give you a minute to think about this. You know what the problem is? You know what the objective? Our objective is to minimize the impact of changes. We want to insulate.
Mhm.
We want to localize
Yeah,
where we want to get close to where the breakage happens.
yeah.
Okay, how can you do that?
Well, I did put a test in immediately after for that to say, oh, I need to specify that.
Contract, yes,
Yes.
make the assumption explicit.
But my question
Contract,
was,
make it very explicit. It will fail
Yeah.
where it's supposed to fail.
but my
Then you can easily quickly fix it, right? If the contract is broken, immediately fix it.
but it was one of, say, 5 or 7 tests that failed.
Once
The other ones were confusing. That one was pretty straightforward. once I added the
do you
test.
remember the component test I was showing you?
With progressively larger showing.
Yes, yes. I had a SUT1, unit test 1, SUT2, unit test 2, and then I put the SUT1 and SUT inside one component 1,
Mhm.
and I had a component test for it.
Mhm.
This component test is what was missing for you,
Right.
because this guy has to be that package. If this guy is independent of everybody else, he has to be well tested on his own. This company has to be well tested on his own. You have to run that guy's test alone by itself.
Okay.
If this guy breaks, you can immediately fix so that none of the other guys will actually fail.
So, if I'm hearing you correctly, you do advocate structuring your tests or running them such that
Make
you
your
test-
assumption explicit.
Right, but you test the
You're
base
like
layer
implicitly, you have the implicit assumptions. You haven't codified. You don't have contract tests.
First. Yeah,
So if you change the contract, you want to
If you
test
change
it
the
at unit
contract-
level,
yeah.
so that you can identify it quicker and then
Quicker, yeah, exactly.
Yeah.
Do the tools in Ruby, RSpec, or others, do they let you specify that, or do you have to set that up outside and run RSpec on this before you run it on that, and sort of do your own chaining of dependencies?
It's kind of like running the unit tests for different layers.
Mhm.
See, the way I architecture, you know the 7-layer architecture, you know this ISO,
OSI.
OSI thing.
OSI, yeah.
See how it's structured. The bottommost layer
It's the physical.
does not depend on anybody else above the guy.
Right.
Every
If
guy
it's
above
broken,
is depending on the below guy. In
Yeah.
your case, that guy was here.
Right, so my question
That
is,
layer needs its own test, right?
but do the tools help you segregate?
Yes, of course, you can structure on your own. You know what I would do? You know how I learned to do it this way? Because I read a book called Practical Object Oriented Ruby by Sandy Metz. She shows exactly how to write this contract test. How to make this, she's a professor at the University of North Carolina or something. How to catch
Sandy
the
Metz.
positive, false negative, when the marks go out of sync with your code base. It also answers that same questions, you know. How do you keep the marks in sync with the real objects? It's all, again, contract test.
Okay,
Read that book, she has a very nice code examples.
okay.
But I do understand that, like, if you change something
Yes.
and then all these other tests break,
Because you have
all this
dependency,
noise.
the arrows
Yeah.
are coming in. If you
Uh-huh.
change the contract,
So you wanna
I
make
said
sure.
it's a well-defined public contract. When you change the interface, it's just like you're upgrading your Braintree API from 1.0 to 2.0. If you break the public API, of course your clients are going to break, right?
Yeah.
So what could we do to handle it? Just, let's say that object is being used somewhere, what
Yes.
do we do?
So what you do?
Use it somewhere
I
else.
have-
No.
Just write a simple test for that object
They
only.
also very
Whether
familiar.
it-
Okay. Let's say you actually have developed a module,
Okay.
okay, to go to Braintree, and you have named this method as charge, and it takes some amount.
Okay.
Okay, it's going to hit the credit card Braintree and then charge the customer and return true or false.
Okay.
Okay, I'm depending on this method called as charge, which is going to take an integer, one parameter, which is going to return true or false.
Okay.
That is the contract between you as the developer of the web service. I'm like application developer working on some, domain specific logic. Okay? We don't have any tests like you were saying. All my tests are passing. Everything is dependent on the charge method, passing an integer, getting true or false. You suddenly, what you do is instead of returning true or false, you start throwing exception now.
Oh.
Instead of doing a nil, you're just starting throwing exception now. All my tests are now breaking because I'm doing if charge, do something, otherwise render saying I cannot, I was not able to charge you, blah blah, enter your credit card again. But the customer has already been manually, you're throwing some exception. You broke the contract. So what I'm telling him is, so if you have a well-defined interface, you are independent of everybody else. Everybody else is depending on you. So you need to have tests to make the contract explicit.
Yeah.
Think about interface in Java. Interface in Java, what does the interface in Java mean? It has a return type, it has a method, and then there's a signature. Anybody who implements it has to obey by that protocol. So in Ruby, we don't have an interface. The closest we can come to is we can come up with a module where you will have a test, where if I provide a positive thing, you should respond to. When you write a test for this thing explicitly, you will write a test to make sure you respond to charge method with one integer, returning true or false. Must return true or false. If you break that API, that test will fail. Then immediately I can localize the defect, and I can okay, this thing is failed. That's why everything else is failed.
Also, a question. So does it also come down to how you order the test? Like it seems like
You should not. You should be able to order the test in any way. Like there should be no dependency on the order which should run the test. That's what keeping tests independent means.
No, like
Isolation.
like if there are several test cases that are dependent on this interface, on this contract, and there's one test case based on the contract, it seems to me it makes sense that the test case that tests the interface contract run first.
Yes.
That allows you to
Yes,
see the
you're right. Yes.
Is there any way for you to structure? Because if there are
No.
so many test cases that are
No,
based on this
because
contract,
see, it's kind of like a layered architecture. I mean, I'm going back to the layered architecture.
so that means you test the
She is
unit
in the
level
boundary.
first?
She's at the Braintree API. That's her API. Everybody else uses her service. So that has to be tested thoroughly first. That layer has to be tested thoroughly, and you have to make sure
Right, so you run-
everybody is depending on her. Aros is going into the public
So
API.
you run unit tests
Let's
first,
say
and then
let's say if I call a third party service and then they are not testing it, and then I'm just stubbing that service, and if that service breaks, what should we do? So something is wrong, right? So that service has to be tested first.
Yes. If you are publishing an API and they are giving you an API documentation, you're programming according to that. So if they change something and if they break something, it's their fault basically. You won't upgrade it basically. If they come up with a later version, if it breaks your API, you don't upgrade. You just found out. You cannot release on that schedule. It's too risky, right?
So if you use a third party API, then you should always have a test suite written for that API.
Yes,
so
you should.
Use it, run a test
So
before
you know
you
if
do
it
any.
changes.
You should. What is the very first thing you do? You go to a company where there is internally there is web services, there is external web services. You need to maybe use the PayPal API, or you need to use the Twitter API, or Facebook API. But you don't know how the API works. A lot of things mentioned in the documentation is wrong, especially in Facebook. So what you do is you write a test to prove that the documentation is wrong. Suddenly, if they fix something, your test will fail, which means they have fixed something. Your test is depending on those quicker things. You can actually see what the impact is. You're in a better position to actually either decide, okay, I'm going to upgrade this, or I'm going to just ignore this. I'm going to, ask for more time from a manager. You know what to do.
So basically, if you're testing any third party service, test the actual behavior.
You need to actually have
Yeah, so that
integration.
you-
Integration test. That's called integration
Yeah.
test. It's going to hit the sandbox.
Yeah.
It
That's
needs to
that
have
you
that
know,
live thing.
yeah,
That's
okay.
how you know the production
Yeah.
code is going to work.
Yep.
Unit test is an isolation. You use tabs
Just
a
to
lot.
test your.
Test locally. Okay.
Yeah.
because you still want to make sure. See, Cucumber test is only going to give you the confidence that all the layers within your application, your system, can work together. How can you make sure something is going to work to the external system? You need to have that integration test as well, separately, without using any stubs or marks, hitting their test environment like marks, the sandbox, for instance, right? Like Authorize.net has like a test sandbox mode. You can specify your test API key and all that.
Yeah. Well, just reference, you've referenced the Kent Beck videos.
Kent Beck videos,
Yeah.
pragmatic programmers.
His examples are using, he's writing a wrapper around Tokyo Tyrant,
Mm.
and it shows him doing this. He's kind of, he has some documents. He's basically sending bytes to and from the server. It's all in Java, which may be kind of hard to understand.
It's like an
Java.
integration test, basically.
But he shows, he's
Yes.
basically building and asserting that this is how the Tokyo Tyrant server works. And
I
that is
would
great.
highly recommend you watch that video, because that's the kind of thing you want to do when you have to interact with the external service API or even the internal web services, for instance, right? Some other team is managing.
Yeah. Yeah, I can, you can get the first, it's unedited, you can get for free like the first 10 minutes or so. It's hard because he will stop and re-say things because he's not edited it together. But you can Google for Kent Beck TDD.
Just if you go to the Pragmatic Studio,
Just now.
they have a Pragmatic screencast.
Yeah.
Yeah.
So minimize untestable code. I'm going to just keep on nailing this one until you actually say, okay, I get this. So what is, we saw the hard to test code, right? What is hard to test code? Threading, transaction, GUI component, asynchronous, right? Asynchronous messaging thing doesn't really come back immediately, right? And also, you could also make your own life difficult by having a looping statement, if statement, and all that. So you want to minimize the untestable code. There is a lot of techniques to actually deal with testing multi-threaded programming, GUI components, have humble dialog, all this. We won't see them now. There is a way to do that. But what is within your control is keeping this test so simple it does not require any test. So how do you minimize untestable code? Don't have any if conditions, no switch statements, no looping through it like you did range, start each, and you were doing all that. Don't do that. If you cannot do that, what can you do then? What if you really need to use the loops? What is the alternative?
Don't they have data-driven tests?
That's one, .NET, yeah, that could be something similar where you could use make the data-driven kind of a thing. What I would do, extract all those things into your own test utility methods. Have tests to test them thoroughly and use that API. And you provide the data,
Like a middle testing layer that does the dynamic stuff.
I'm saying try to raise the level of abstraction. If you have to provide a range and you need to do, let's say you need to do all that, provide a range and do all that. Can I just have a method that takes the range and it does the check for you and you name the method accordingly and it returns you either true or false, whether it passed or not? You'll be happy, right? Not only can you use, I'm in the same company, I can use your library now if you have test covering all the scenarios and make sure that it works across all different possible conditions, right? So I can reuse your test utility method. I can benefit from it. Data-driven thing is one way. I've seen the .NET guys actually do it in the code itself by providing, it's like a fitness kind of a thing, right?
Yeah.
That's one option. Having your own test utility library is another option. Okay. The point is to actually don't be too clever in your tests. Make it very simple. Simplicity is the most important thing in your test code. Okay. Okay, now you spoke to your customer and you are very clear on what they want from the system to do. You're clear on the behavior. Okay, now you have this like themes and you have stories, and now you put the stories into some some product where it allows you to check out the task and start working on it. So starter test. So the question is, what should be the first test? Right? You have like laundry list of things to do. Like you have 5-10 things, right? And you just have you're describing your class, and you have it should do this, it should do that, and you have like 5-10 things in there. So how would you go about picking the first test to write? Now we know the structure, now we have the requirements, now we have to write the first test right now. So how do you pick the first test? Simplest? Anybody else agree with TOEFL here?
In the agile, like if any story comes, then like highest priority thing we take
Okay.
first, and then
So based on
the-
priority,
whatever
okay.
feature they want.
Anybody else for priority? Who is for priority and who is for like simplest thing here?
It's hard.
Okay, let's say I pick the simplest story. The story has been broken down even further, like 5-10 tests. I'm talking at that level. You're looking at the code editor, and you need to pick the test. So I'm working at the high priority, charging the customer that's going to bring me the money. Okay, I'm asking you, what is the first test to write? He is going in the right direction. That was also right. That's like one level above.
Well, definitely a happy path. You don't want to start
Happy path. Okay. So anything else?
Just go down to the really base level, like the class, just make sure it has the right attributes, properties, I don't know.
Yes. Actually, you write a test which is so trivial it does nothing. Return a blank string, return a 0. That's what we did in the example we had. Like we started with 0. I just happened to give you that first sequence which was 0, 0. What is the point of actually doing that? What did you gain out of it? Writing that first set which was written with 0.
Encouragement, because
You set up all the different things that you needed, right?
Uh-huh.
Starter is all about getting started, giving you that impetus you need, right? Okay, describe, statement, oh, I need to have this, I need to. It's not Ruby, spec, RB, it's RSpec. You learn how to use that framework API, you learn the syntax, you found out all that, you refer the documentation, okay, this is how you actually use this API, this is how you have the doc string. Oh, it is a method, it takes a string and okay, fine. And you did the most trivial thing. Why did you do the most trivial thing? That's the quickest way for you to start getting feedback. I always want feedback. It's all about, okay, my idea is here, I am implementing my idea. Is my idea right or not? Only running the test will tell you whether you're right or not by looking at the green, right? When you get to green, okay, you're right. It's confirming that belief, okay, you're going in the right direction. Okay, now I've written the first test. How do I go about picking the next test, second test? Okay, I feel good. Now it should return 0 for 0. How do I pick the next test? What is the second test?
Yeah. Next incremental on top of that?
Yes, what is the next? So what do I gain by this? I'm slowly learning about the problem. I'm slowly gaining confidence over time. It's a learning process, basically. It's a learning process, getting accustomed to the tools that you are using, getting accustomed to the API, getting accustomed to the problem. You slowly gain confidence. More confidence you gain, you don't have to take baby steps anymore. You can take longer steps. As long as you can get to green quickly, you can take bigger steps if you want, if you feel confident. Okay? So it gets progressively more and more difficult. Eventually you have to solve the real problem, abstract, you have to get to the abstract solution, right? So that is a starter test. We know how to pick the first test to write. What is the one-step test? One step in the sense, you always pick the next test. It takes one step closer to my overall goal. One step closer to my overall goal. Overall goal is, I want to write a Fibonacci sequence. I want to be able to calculate a Fibonacci sequence of any number. That's my ultimate goal. But I want to get one step closer to my goal. So what is it? Minimal thing that I'm comfortable. I know I can pass this test quickly. I know I can write this test very quickly and make it get to green. I will come and I pick that and I write it and I make it pass and I move on to the next one. Okay? So the learning test we already saw. If you have external API, I don't know how the brain tree works because we did not write this API here in-house. and the documentation says this is how it works, but I don't really know how it works. So I'm going to write a learning test. Okay, the learning test is what is going to validate the assumption or the documentation, whether it's lying or whether it's telling you the truth. You'll find all the bugs in the external vendor's documentation, and you retain this learning test over time, and it provides value when you're going to upgrade the library, external library, right? Okay, explanation test. This is actually, everybody is in a situation where I want people to adopt TDD, and even though other developers don't have the discipline to write the test first, another developer comes to me and start talking to me about how the system should behave. I give the explanation in terms of tests. Oh, given this setup, if I do this exercise, this is what I expect to happen. Given then when I actually explain in them in terms of test, is this what you mean? Is this what you mean? Yeah. And then I write a test, explanation test. You may say something to me while I'm talking to you, but when I go and actually get the test to work, that assumption may not be true. Only the test can tell me whether you're like right or wrong, or maybe you just forgot to mention one minor detail because it's kind of like vague, right? There can be no vagueness in test. There's only like pass or fail. There is no maybe, right? It has to be clear and precise. And the test cannot lie. Sometimes there is false positive, false negative. That means it's lying. So another test. So this is something like, for instance, you're like writing a controller. Some logic is getting messy, and it should be a thin controller, fat model. You know what? We should actually move this thing to the model layer. Let's write another test at the model level, and then we'll come back to the controller. Write another test. Don't get distracted, which has to be put a pending in your controller. It's pending this. You move the logic into your model test. Make that one pass, and then come back to your controller. You can remove the pending and get this thing working using the new API that's in your fat model, right? Just don't, sometimes it's not related. Something is distracting you, which is not related. You just put it in your to-do bucket. You're having a pair programming session, and suddenly you say, hey, what happens if this, and all that? You're just trying to divert my attention. If it's not related, I put it into my queue. Oh, that's a very good point, Toffel, you brought in. I think that will have business value. Let's put it into a to-do list. It should do something, blah, 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 pending. We'll come back to it later. So you go back and focus on what's actually you're working on right now. It's another test, later, pending, okay? So the regression test, when a bug comes in, you actually are ideally supposed to write a test that's going to expose the bug. Okay, the bug exists, and you fix it. So the failing test now passes. So bug has been fixed. It hasn't broken anything. And then the question that you ask, that's the regression test you wrote to fix the bug. And then the question that you ask yourself is, where else in our system can a similar thing have happened? Where else can a similar thing have happened? You're basically trying to see my safety net, the holes in my safety net. I want to make it smaller, so I don't get more regression bugs, going through. It's just giving a regression test. Just means you're not. The system is telling you you're not done designing me yet. Okay, you haven't sufficiently have enough coverage to be confident. Okay, this is gonna work and provide business value.
What is explanation test? I just missed it.
Regression test.
Explanation.
Okay, one second. Explanation test is like basically you're in an organization where TDD is not really the thing, and you're asking something. They're asking something about the system, or you're asking for clarification from them. Okay, but the way you communicate is using that structure I showed you, the 4-step, right? Given and then, or setup, exercise, verify. Oh, is that how this thing was supposed to work? You capture that, and so that you can write a test for that. So you get to the developer conversation, you get into that structure. So it's kind of like you're learning more about the system. Maybe you're new to the company, and this thing gives you a framework to talk in a very structured way, and also make sure whatever the information they're providing you is the right information. Use TDD to write test utility, like you said, the range checking that you were doing. I could just have a assertion for custom range check or something. I could name it domain specific way, but you need to have a test to test them so that it can work across different data set, catching the boundary condition and all that. So use TDD to write the test utility so the others can use it. Okay? Because I want confidence. I want to make sure there is no bug in the test or the library that I'm going to use across all of my tests. Okay? So this just kind of shows, at the setup level, you can have a creation method. It's like a factory method, okay? If you're using a factory girl, that is basically the creation method right there. You don't have to write your own utility. And then finder method, you won't really have much finder method. Exercise phase, encapsulation method, this is when you're actually exercising the behavior, sending something. Verification stage, you have verification. These are all like custom assertion, even verification stage. Cleanup method, if you want to clean up your resources, if it's very specific to PayPal thing, you want to have a cleanup method that you can reuse across all your integration tests, for instance, right? So each of these things raises the level of abstraction depending on what step it is. It's just named differently. It's all test utility methods, and you have tests to actually test these methods. Your domain-specific different tests that you're going to reuse across different, modules, classes that you might be testing. So don't have any loops. Keep the test simple. No if statements. If, but, all, else. No switch. Okay. No each, for each. All those things. Why do we say you don't really need to have loops, conditionals, and all that? More conditionals you have, more code paths you're going to be having in the test, and more difficult it becomes to reason how your test is actually going to behave at runtime, right? You don't want that actually. You want it to be able to just by looking at the source code immediately. You need to be able to say, okay, I can exactly say what this code is going to do because it's so simple. Okay. Our conditional test logic, we saw that expected behavior specification. You can actually, if you have two objects, like we kind of discussed this thing, you can pass in those two objects because we already know we want to aim for just one condition, verification of just one condition. What if you need to have like a customer? I want to assert, okay, the customer was charged. The amount was paid was this thing, this was the amount, all those things. If I want to have multiple assertions, I don't want to do all that. I want to just say, okay, here is the customer object. Do whatever assertions you want. It's like the internal library utility will do all that for you. Okay, that's the expected behavior specification. You can write your own stuff. It just takes the object and it asserts on different things that you really care about. This built-in assertion RSpec comes with a lot of built-in matchers, delta assertion, and Boolean thing and all that we saw. I will give you a very quick tour of all the RSpec related built-in assertions, like more like a crash course. Really breeze through them towards the end of it. Okay.
Yeah, actually, I want to do like sometimes if you have to create. I have seen like some people using as a null object, some methods as null objects.
Oh yeah. As null object.
Thing, I don't know.
Yes, I can actually. Just remind me as an null object once I finish that thing. Okay, I'll tell you when you use it and why you use it. Okay. Domain assertion, very specific to your business logic. This is the domain specific assertion. Raises again, it becomes more expressive. Sometimes you start to have like puts here, puts there, and you want to see what's going on, right? What is the expected value? What is the what's happening? Instead of using puts, just write your own diagnostic assertion. That's going to say, okay, this was expected and this is what you got. This is what I got. It's very, very self-explanatory. When you run this assertion, you will still have a puts but it's basically assertion, and it's more. It gives you more diagnostic information. Okay, instead of having puts everywhere, you
Don't put puts in
don't
the
don't
code,
don't
but
put
do assertions.
yeah, exactly, put diagnostic assertion, so it provides you. If you need more information, see, if you're using a debugger, the main reason for all this TDD is you don't spend like 3-4 days trying to hunt that one elusive bug, right? You don't want to spend your time in the debugger. But putting puts is basically kind of like a substitute for not being able to inspect variables or look at that particular attribute value, stuff like that, right? Instead of doing that, create a diagnostic assertion and use that diagnostic assertion, which will show you what are all the values of that particular object. Are you interested in? You can have a custom 2S method for that customer object, and you can say the customer first name last name has this something 2S, which will make sense when it is output to the standard out. So you will know, oh, okay, this customer was charged twice, or you can, but just by looking at the output, you can get a lot of clarity on what's going on.
So basically, for example, I was debugging a nested code with a lot of logical branches, like if conditions, and the code is not, like with a particular input, it's not taking the path I expect to go. So I had to put a lot of puts throughout the code in order to see.
Here's the thing,
where it's
especially
logical.
if it's a code that you have not written, somebody else has already written the code. The only way you can learn about the code is by putting the put statement in there and running the browser or checking to see, okay, is this?
No, this is my code.
Okay.
This is my code. It turns out because the input object wasn't the right class. So you're saying instead of using puts, I could just write a cert statement in my TD test case.
You can actually
tell me what's the result of this evaluation.
You can write an assertion, custom utility for your object that can take that particular object, or you can write even a general one, as long as your object can respond to 2S and dumps all the attributes for that particular object.
Basically, essentially writing what's in my if statement and then sort of assert whether that's true or false, because I expect it to be true, it turns out it's false.
Yeah, I can have a guard assertion instead of if statement.
How do we do that? How do we do that? Like, let's say in her case, you want to check the class, right? The object is not right. You're saying.
Right.
So you're saying.
For example, I expect it to be hash, but it turned out it was a string.
Ah. Yeah, that's a good one.
So if object is an instance of this, you could check like that, or?
No, basically when you start going towards, when you start checking towards instances and that, those kind of things, you're going to lose the benefit of polymorphism. As long as certain thing responds to a certain message, I don't really care if it's a hash or an array, because they all respond to each, for instance, and they yield the values and keys, values. But for your case, your assumption was something was supposed to be a hash, it turns out to be a string.
Mm-hmm.
Yeah, basically you're still actually, you're debugging basically. What I would suggest,
But you're saying diagnostic assertion can be used for debugging.
diagnostic assertion can be used for debugging in cases where you want to dump the particular object and you want to inspect the variables. What are the values in the variables? I want to see. See, what do you do with put test? For
Yes,
instance? You want
instead
to
of
see.
doing puts it, he's saying instead of like just how we put loggers, he's saying
Yeah.
just do inspect, and that way you get to know like what were the object values and what is missing.
Yes,
Right?
basically. That's
He's
what
saying this customize the 2S method, and 2S method will print all the.
print in a very legible way of,
You're saying
Human
doing
readable
that
format.
inside the code using
Yes,
Yes.
not using diagnostic assertion in TD.
No. This is in some cases where you need to inspect, you can do the diagnostic assertion. Okay. In your specific code example you gave me, there is a lot of if statements and going all this thing. You are testing too many things at once. Okay. Usually, look, if you're writing a test, I showed you like 4 steps. In the 4 steps, in unit test, that became to just 3 steps. So if your test is going beyond 3, 4, 5 lines, if you follow that one of the test guidelines which says, verify only one condition. You only have one assertion, you only have few objects you need. The minimum object, you always create minimum objects you need to test your system. Context should be minimum because you don't want to create too many objects, which is unnecessary for whatever you're testing, because you want to reduce the test context because you want your test to be faster. Okay? So if you do that, your test will be like 4 or 5 lines at most. If you are like having a longer test, you're testing too many things at once. SUT can be too large. That's one of the beginner's mistake again. If SUT is too large, you're testing too many things at once. It's called as an eager test. It keeps going. It's like a poetry. It just keeps going on and on and on, verifying this, that, and every other kitchen sink under the.
Let's say I have a 3 or 4 levels of nested if statements. Can I just break each level into a single test case?
Okay, here is a question for you. Can you write tests without writing any if statement? Can you challenge yourself without using any if statement? I have a constraint for you.
No.
There is
I'm
no
talking
if-
about my code has if statements.
You have like a nested four if statements, you said, right?
Yeah.
Whenever you are using if statement, most likely you're not utilizing the polymorphism to the full effect. You're depending on something, you're, like she was saying, instance of, you're checking some instance of. What is it in the conditional that you need to have so much of, nested ifs, first of all, right? Maybe, the thing is like, maybe the object is not following the single responsibility principle, for instance. You should do one thing and one thing only.
Actually, in this case, it's not really object. It could be like a user input text where, the type of message.
Mhm.
Based on the type of message, I look at the status. Is it fail or successful? I take different kind of actions.
Uh-huh.
It's not really.
I think there might be a way to refactor the code to reduce
Yes.
some of those if statements, but there are different techniques for that.
The
But-
command pattern, for instance.
But if I'm hearing you correctly, you would probably recommend having one test method for each of those different.
Yeah.
Yes, I would
That's what I'm
break
saying.
and everything inside of this. I will break it into separate tests on its own.
Right. So each level is a separate
Yes,
test case. That's what I was asking.
Exactly. That's right. The one thing I was like in the kind of confused was like you were mapping that whatever the user is pressing to some other command or something else which is going to happen. Mapping of that also you can use polymorphism for that.
No, actually, in this case, it's not a Rails object
Oh.
because I'm getting users SMS message and it has a specific format.
Mhm.
So it depends on the message. The message has a few fields. So
Mhm.
it depends on the value which field I need to process it differently. Because it's not really an object.
I see.
It
It's
is-
more like a mapping of events to a handler. Event
Right.
handling. Yeah.
But you might be able to abstract it to a factory that gives you the handler, and then all of that, the ifs are just in the factory, but the behavior is separate. That's kind of more OO refactoring stuff. But I'm just imagining what
Are
I'm
you talking about TDD or you're talking about?
No, this is something else, yeah.
See, TDD and design are, you cannot talk one without the other.
Yeah, and I don't
When he's
know
talking
that
about the design, yes, he's on the right path. I totally agree with you. Your code is too procedural. Okay? When you're using TDD, you see the first goal is to drive the design of the code. This is a sign of, this is what I was saying, listen to the test. If a test has to be like this, there is a pain there. If it's going procedural, I'm saying no if, no loop. You cannot, I'm imposing a lot of constraints here. Why? I want to make the test very simple. And the pain is here. Pain is here, but it's giving an indication that design needs to be improved. Okay? The event handler mechanism, the way you handle it, you map the event to the behavior, publish events, somebody subscribes to this event and they handle it in their own way. Behavior changes based on the event. This are like, sounds like polymorphic to me. You have to use more polymorphic, dynamic kind of a dynamic messaging kind of a thing. You have to isolate those behavior, encapsulate being a well-defined interface. Okay? Because you cannot just leave that kind of procedural code in the test. It's giving you feedback that you need to think about the design. think more about the design. I would actually read the Eric Gama's, design patterns book, and some of the things that they talk about, you can actually find the context and the scenario and see if your problem actually fits one of the things that they're talking about, and you could follow one of the, how they go about. Design patterns. Eric.
This code is very low-level code.
Oh, you're talking about low-level code. I
Very
don't know.
low-level code that process a SMS message that I'm getting. I need to do some basic processing.
Basic processing. Maybe I don't know. Maybe it's too low
So
level.
therefore, it has a few nested if statement because I need.
Few nested, yeah, it's okay. To me, initially, it looked like you're getting different events and you're handling in a different way. The behavior changes.
But if I'm understanding you would recommend that having different tests from different code paths. so
Yes.
your tests aren't
Yes,
having different code paths in them.
that is totally true. Because I really want to nail this point. Because the reason is you don't want to have different code paths in the test is whenever I run a test, it has to be repeatable. I need to deterministically say this is the code path it took. I run it 100 times. I need to say, this is going to go through this path 100% of the time. If it's going to go through a different path, you need a different test for that.
Yeah, I understand about test part.
Yeah?
Yeah.
Okay, so that's fine. If it's too level, I don't know if any of my suggestion is going to be applicable to that thing. Okay, so the verification method, you see, we encapsulate all the verification logic specific to our thing into our own utility. That's the verification method. Custom assertion tests. Let's see, if you write your own custom assertion, make sure you have a test for that. Unless you have a test, you cannot be confident you can reuse across all your other tests, right? So sometimes what happens? Sometimes things are going right. Sometimes everybody gets stuck. We all get stuck. Nothing is working. Maybe today is just like that. I don't know. But no matter what you're trying, it's not working. So what do you do in that case? Throw away the code and start over. That's what the do-over is. You're all stuck. Start fresh. Take a 5-10 minute break, and then start fresh with a different. Maybe change your pairing partner. Get a fresh pair of eyes to look through the problem a different way and discuss and see if you can make progress. Right? So it's not like every time everything is going smooth. It's like some days are very frustrating. Yeah. So it happens. And also, when you're stuck, what do you do? When you're just programming by yourself, you're just stuck. You just cannot actually work through this and make any progress. What do you do? You're just stuck. Break. That's what the break is. So let's see how much more we have. Okay. So here is a question for you guys. How big should my steps be? How do I know how big my steps should be?
That's a clear rule. Don't spend too much time in the red area.
As long as you're green, you can keep on taking longer steps, right? If you're getting to green and you're getting quick feedbacks, you don't have to keep taking smaller steps, you can take bigger steps. And if you're red, it means don't take too longer steps, just start taking smaller steps. So what don't you have to test? Otherwise, how many tests should I have? Should I have like for Fibonacci, should I say I should have like 5 tests, 6 tests, 50 tests, 60 tests? How many tests is sufficient?
20%.
Oh, 100% disk coverage? Are you happy? I have like 4 tests and it gives you 100% disk coverage. Is it sufficient?
80-20, so 20%.
Some numbers, doesn't make any sense, right? So the thing is not about how many tests you write or what is your disk coverage. Yeah, 100% disk coverage is good to actually aim for. The thing is, how much confidence do you have in your code? It's about confidence. It's about the fear, facing the fear. It's how comfortable are you about making changes to the existing code to fulfill the new requirements, satisfy the new requirements, changes, right? It's not about validation. It's all about specification, right? Driving the design of your code. So there is no one specific number that you can calculate and say, okay, this is the number of tests you have written. Now we can stop. So how much feedback do you need? I always want quick feedback. I don't want to spend too much time in red. Being green, I want to have that loop. I want to minimize that loop. I want to get a lot of feedback. Feedback is what allows me to learn, to experiment, right? To take different alternative solutions. That also gives me confidence. If it's all green, it gives me more confidence. I can try much more bigger things. And then we will see. I saw you delete the test. And so why did you delete the test? When would you delete the test? When is it okay to delete the test?
When another covers that completely, or no?
Yeah, whatever answer, just back it up. Yes.
Mm-hmm.
Sometimes you write a test. It doesn't really test that much. It just kind of like it gets you in the right direction, and you learn something, and then you have another test. Kind of like you said, it covers the previous one. So the previous test does not have any purpose except for allowing you to learn more about the system. Oh, there's no more purpose for the test. You just delete it.
Redundancy.
Okay, that's okay. So I'm working in a different team, and TOEFL is working in another team. We have been like pair programming and we've been rotating. We ended up writing tests, which is very similar, which is testing the same thing, but we wrote the test in a different way. So do I want to delete my test, or will I delete your test? Which test should I delete? Testing the same thing, right? But it's written in a different way. The dark string is different. The way we have set up and the way it's structured is different. How would I delete it? Since it's kind of like a duplication, right? Which one should I delete?
Less relevant, but well.
If it is irrelevant, if it's like a total duplication, if it's irrelevant, it doesn't matter which test should be preserved, you can delete either one of them. Or if it's different enough and it has communication value, the way he's emphasizing, the way his dark string is, provides value for his context, for his object, and it provides value for mine. I will just retain them both anyway. Because, go back to the goal that we had previously, communication. Communication is one of the values that the test provides, not just, this overrides the thing I said before where you should minimize the test overlap, should not have repeating the same test over and over again. But this provides communication value to the team members. Yes, I would retain it. Right? So you need to know what the goals are. So you have so many different things that you need to balance, and you make a choice. You have to make a judgment based on what the circumstances are for that. So we'll see what this round trip test is. Round trip test basically is a test where you use the public API. I've been saying use the front door first. This is the front door. Front door is nothing but the public API. In this case, is a real component test method 1 and test method 2, exercising the SUT. SUT is a public API, that's why I'm able to directly call it. And there is a dependent on component. It collaborates with some other thing. Okay, this is the shopping cart, to be concrete, tax calculator. I want the calculator, and then I need to calculate the total charges that needs to be charged to the customer's credit card. And then I am returning that value. Okay? That is a round trip test. It goes one round trip, Because input, it returns some value to it. and it uses the public API in round trip test. Okay, that's a real component test. The fake component test, you create a fake object. Fake object can be a stub or a mock. We'll see what the differences are pretty soon. We create this and we install this fake object on the SUT, which means in the test environment, it's going to use the fake object. So this is grayed out. Dependent on component is not used in the test environment. It will be used only in the production environment. This thing will be. But the fake object is the one which is going to be used. So this is a fake component test. It makes the entire thing run faster. So if this is a calculation of tax calculator, this is a fake tax calculator. You just take some arbitrary number and just says, okay, this 6%. Charge this guy 6% sales tax. That's what it says. It shows quickly. It doesn't go to the database. It doesn't look up anywhere. It doesn't look up the web service, internal web service, anything. It's really fast. Okay. And now compare and contrast this to the layer crossing test. The first one was round trip test. Second one is a layer crossing test. The first one you did not have any layers. Now in the layer test, you have layers coming in, layer 1, layer 2, layer 3, layer n. For this particular layer, I'm only concerned with this layer. I don't care about this layer. I have a test double there that replaces the entire layer. The layer beneath is also replaced by test double. That particular layer is isolated from the layer above and the layer beneath. I'm only worried about that particular layer I'm about. Test concerns separately. That's what this layer test. Each layer is tested independently. Layer 1 is tested independently. I replace the beneath and above with test double. So I have more control over the behavior of those guys and so on. Layer n, the same thing. Above and beneath, they are all separated. So depending on component is grayed out. It's only being used in the production system, not in the test environment. Okay. Divide and test. Yes, layer by layer, it's divide and conquer basically. Each layer you test them separately. The bottommost layer is independent of everybody else. It's divided from everyone else, isolated from everybody else. You just separate them, like you were talking about. How do I make sure if you change the contract? If you divide and test, you will localize the change, and you can actually make the test fail closer to the actual cause of the problem, which helps me to localize the defect and fix it quickly. Okay. How to manage test fixture? We kind of like discussed this thing in the morning actually. For instance, if you're using a factory girl, for instance, you have a happy path for all the happy paths. I have a valid user with a valid first name, last name, email. Everything is valid. Phone number, everything is valid. If you're checking the validation for phone number, you override with the invalid phone number. You override so your test is clear. That's how we manage test fixture. It created once. When you need to override them, you override the only specific thing you need. Okay, and all of this thing, you don't have to manually worry about these things, mainly because if you're using something like a factory girl, it's going to take a lot of this burden away from you. You don't do this thing. You just go by how they recommend you create certain objects here and override them, and you just use it. You just know how to use it. That's it, right? How to structure your test and use a factory girl API, and that's it. The framework actually worries about whether it needs to create that object, new object, and then replace them, or just do an update and that particular email field alone and just provide that object. It's all like happening behind the scenes. You're not explicitly as a programmer, you're not doing it, you're not controlling it. Okay.
So I can drop. Has anybody seen this error before? I don't know how to the management this.
Oh, system crash.
Yeah. Are you having slow upload or what is it? I think it crashed.
That happens on mine all the time.
Oh, really?
Mine's a PC, so it's not supported.
Oh, I see. Actually, we need to take this thing to the store. It's not, how often is that?
No, this is the first time we have it.
Then maybe it's a one-time issue. Okay, that completes actually the testing guidelines. I just want to take like 5 or 10 minutes break before we actually move to the bad tests, good tests, and stubs and marks. That completes the testing guidelines as well as the how to write tests. So we have like a few more things to rush through. Maybe we can just take like a 5 minutes break. So we come back at like 4:30.
Is anyone using the BIM?
Yes.
Do you use Spork as well to speed it up? Spork?
Spork, no, I don't know what that is.
Okay.
Um,
It's instead of building everything each time you run RSpec, it's sort of like a cache.
Actually, you know what? All this sport, this, that, and all that, I wouldn't actually use those kind of libraries.
Really?
See, the basic problem is your tests are slow. How do you deal with this? Corey Haynes actually has given a talk, and you basically extract all the behavior into your own module, and you mix in to your stubs, and you test them separately. Okay, so that's what people have. You make your test faster. See, more dependency you have on things like crazy stuff like the Spoke and all that is just too much dependency, and a lot of things break. It's not.
I do
you're
find
spending time on things you should
it
not
can
be
be
spending
hard,
time.
because yeah, like if you change your route or whatever, config routes, I didn't realize I had to, restart Spork each time, and I
Mhm.
didn't realize why it was failing, and it sent me off on this other path.
Oh, so is Spork a process that goes in the background and reports back
Exactly.
through them?
Yeah. I do find it speeds it up,